Hello, Curran here. This video is about making this line chart here with multiple lines. If you followed the previous videos making line and area charts and color and size legends, and you're interested in making line charts with multiple lines, then this video is for you. The topics we're going to cover here include using D3.nest, rendering multiple lines, making the lines different colors, some aesthetic things like line caps and blending modes, adding a color legend, and finally sorting the color legend to match the lines. Recall from the Marks and Channels video that this technique, or visualization idiom, uses lines as marks, and it uses X position and Y position to encode quantitative attributes. And the different lines represent different values for a categorical attribute. And that categorical attribute is also differentiated using hue in this case. What I'd like to do here is make it so that this line chart uses multiple lines for multiple cities. See, this is showing the temperature variation in San Francisco over a 1-week time period. But I've got a version of this data set that has multiple cities. See, here's the timestamp, the city, and the temperature. And if you scroll down, you can see that there's other cities like Bangalore, Boston, Geneva, Rio de Janeiro, Shanghai, and Singapore. The idea is that each of these cities will correspond to a different line in the line chart. The first thing we need to do is get this data into VizHub. So I'm going to click on Raw here. This is the CSV data, and then I can click Save As. Save the file. Then over in VizHub, I'm going to say Upload Dataset. Then I'll choose that CSV file, week.csv. Then I'll rename it to Data Canvas Since Your City 1 Week. It's from the same source as this original temperature in San Francisco dataset, so I'm going to say over here that the source name is Data Canvas Since Your City, and for the source URL, I'm going to copy the same URL as this other one, paste it in here, and then click Upload. Alright, now this dataset has its own page and its own URL that I'm going to copy and paste over in our code. We don't have any code to speak of yet, so I'm going to get started by forking this line chart example, and then I'll rename it to Line Chart with Multiple Lines. Over in our index.js, let's see where it's loading in the data. See, down at the bottom of the file here is where the data is coming in, so I'm just going to swap out this URL for this new one, for this other data set. And check it out! Already we see something. These lines look like kind of a mess, but you know, we're starting to sort of see multiple lines here. But the thing is, it's actually a single line that sort of winds back around to the beginning for each different city. So let's make the necessary changes to have this be multiple lines. The data parsing logic still holds, so we don't need to change anything there. We just need to change something in the render function. Just to quickly review what's going on already in this render function, we're setting up the title, the X value, and the Y value, the margin, the X scale, the Y scale, the group element, the axes, the axis labels, and then we're creating this one path element and setting it to be the line generated from all the data. But what we want to do here is have a single line for each different city. So we need to somehow split up this data, which is a single big array from this CSV file, into multiple arrays, one for each city. So right here, let me just say console.log data to get a sense of what we're dealing with here. Console.log data. We've got one big array that contains rows for all the different cities. And within a single row object, we have city as an attribute. To split this array up by city, we can use a utility called D3.nest. Let's use D3.nest. If you do a Google search for d3.nest, this example on blocks.org by Phoebe Bright is a really good one for figuring out how to use d3.nest. This is my go-to source when I need to use d3.nest. So you create an instance of d3.nest like this, and then you call .key to specify the accessor function that it should use to split up the array into multiple arrays. And then you call .entries and pass in your array. And what you get back is an array of objects, each of which has key, the value returned from this key function, and then a values property. The values property contains an array of the original rows from the data where the key function, specified here, returned this particular key. See, in this example case, it's d.status. The status here is complete. That corresponds to the value of key up here. And if I scroll down and find another entry, see, here's another key of not started. The status is not started for all of these entries here. Let's apply this to our code. I'll make a new variable for our nested data, and I'll call it nested. And this is going to be the result of d3.nest, which we invoke as a function to create an instance of it. And to have it available to us, we need to import it from D3. So I'm going to go up to the top of the file and import nest from D3. Then going back down, on our instance of nest, we can say .key and pass a function that takes as input d and then returns d.city. And then we can call .entries and pass in our original data array. Now let's console.log nested and take a look. When we say console.log nested, we get this array that has 7 entries and 1 entry for each city. And the values array for each of these top-level entries is the array of original rows where the city corresponds to the key here. So if I unpack this, we can see that indeed the city is San Francisco for all these entries here. Now let's change around our code to add multiple path elements instead of just one. Instead of just g.append path, we can use a data join and say g.selectAll. And since these paths already have a class, I'm going to select on that class. So select all dot line dash path dot data, and for the data I'm going to pass in nested. So now we have our data join for the line paths, and on that data join we can say dot enter dot append path, give it a class of line join. And this .attrd line generator of data is not quite right anymore. See, what's happening here is it's creating 7 of these gnarly lines on top of each other. To make it generate 1 line per city, we can change this around to take as input D, and keep in mind D here has key and values because our data is this nested array. And then we can say line generator of d.values. And now, voila, we get multiple lines on our line chart. Alright, that's the essence of line chart with multiple lines. From here on out, what I'd like to do is make it so that the lines each have a different color, and also I'd like to add a color legend so you can tell what the colors mean. Let's make the lines different colors. So I'll get rid of this console.log there. And just like we've got X value and Y value, let's have another accessor like this called color value, and that's going to be the city. So instead of putting this function inline here, I'm going to use a new variable called color value, like that, And color value we need to define along with X value and Y value. So up here, I'll say const color value is this function here that returns the city. And then in our scales section, we've got X scale, Y scale, and now let's add color scale. And let's make this an ordinal scale. We can say scale ordinal. And for the range, I'll just use category 10, sort of my go-to color scheme. And both of these, I believe, are not yet imported from D3. So up here, I'm going to go ahead and import scale ordinal along with our other types of scales, and also category 10. Or, you know what? I think it's actually scheme category 10. Yeah, it's scheme category 10. So when we construct the scale, we pass in scheme category 10 as the range. And then we need to set the domain of this color scale. And the domain, it's actually all the keys from the nested data. So we could say nested.map. Then we take as input D, one of those nested objects, and we return D.key. And I'm realizing nested is not in scope here, so I'm going to separate this into two different statements and then move the statement that sets the domain down until after we have our nested data like this. And now that we've got this in place, we can set the fill, or no, the stroke attribute on our lines. .ettr stroke. And the stroke we can set to a function that takes as input D, one of our original rows, and it returns color scale of color value of D. Or no, D is not one of our original rows, it's one of our nested objects. So this really needs to be D.key, not color value of D. D.key, that's the city name. And I think we're not seeing the stroke change because we have some CSS that's overwriting the stroke. Yeah, in the line path, we're setting the stroke to be maroon, but if I delete that line, then we can set it through JavaScript. All right, we get colorful lines. Look at that. All right, we've got multiple lines that are different colors. At this point, I want to sort of geek out on the aesthetics of things just for a little bit. Let's look at some aesthetic aspects like line caps and blending modes. One thing I'm noticing is that the line endings are square, but I would like them to be nice and round. So I think, just like stroke-line join, I think there's a thing called line end. No, it looks like that's not it. I'm going to have to Google this one. If I Google SVG path stroke line end, oh yeah, there it is, stroke-line cap. That's the thing that we can set to round. Stroke-line cap. We set to round, and see that now we get these nice rounded line caps, or line endings. And notice how some lines are on top of other lines, but there isn't really any sense to that. So let's fix that one issue by using blending modes, and this is something I learned from Nadi Bramer. I would highly recommend this course on Skillshare by Nadi Bramer, Data Visualization Customizing Charts for Beauty and Impact. That's where I learned this trick about blending modes. If we set the mix blend mode to multiply using CSS, which I can do with just that one line of code, see how now where the lines overlap, there's not one on top of the other. The colors sort of blend together in a nice way here, where you can see that there's multiple lines, you can see clearly where they intersect, and there's no arbitrary, Z ordering between these lines anymore. So now let's finish things off. I'm going to change the title so it's accurate again. Back in index.js, here we've got the title. I'm going to change it to a week of temperature around the world. And now the text goes off the edge there, so I'm going to make it smaller. I think we did that in CSS. Yeah, down at the bottom, our title is being set right here, the font size. So I'm just going to tweak the font size to make it so that we can see all of that text. 2.7 looks like a good number. And now let's add a color legend. I'm going to use that color and size legends example from earlier. And I'm just going to grab this whole color legend component. I'll make a new file over here called colorlegend.js, and then grab this code from that example and paste it into this file here. And then over in index.js, we can import colorlegend from ./colorlegend. And then I'll go back to that other example to see how this is invoked. Here's the invocation here, so I'm just going to copy that and paste it into our code here. But where should we put it? I think I'll put it down where we have the color scale domain defined. I think I'll just put it last, actually. So I'll just paste it right in here. And just like that, it appears. All right. But our circles are blue. Is that coming from our CSS? Is there anything sitting? Oh yeah, circles, the fill is still blue. I think that's just left over from some older example, so I'll just delete that. And now we get the properly colored circles. I'm going to tweak the right margin to make room for our color legend. And then let's tweak the color legend itself, the props that get passed in. Now I'm just going to tweak out the spacing, circle radius, and translate for our color legend to sort of put it in the right spot and give it the right size. Now the text is kind of far away from the circles, so I'll tweak the text offset as well. Alright, now I think the only thing that really needs tweaking is the font size for both the color legend and these ticks here, which are uncomfortably close. So over in our styles.css, I'll tweak the tick text size. Now the x-axis ticks are more readable. And now I'm slightly confused because when we set the font size of the tick text, that should apply to these ticks as well as these ticks, because after all, these groups have a class of tick. I'm going to inspect the DOM here and try to get to the bottom of this. Alright, here's our x-axis tick elements, and then here's the group element for the x-axis, and see that the font size is set to be 10 by D3 axis. I think this is our issue here because when you use EM, it's relative to the parent. So the way we can solve this is we can use the unit REM instead. Now when we tweak the font size, it applies to all ticks equally, whether they're in the axes or the legend. Now we can go back to index.js and do a final pass on tweaking the margin and the color legend. One last thing I'd like to do here is make it so that the sorting order of the color legend matches the order of these lines at the very end. This would make it easier to read the color legend and correspond the values to the lines. Let's sort the color legend to match the lines. One thing to remember here is that the ordering of the color legend depends on the ordering of the domain of the color scale. So if we want to change the ordering of the color legend, we need to change the ordering of the color scale domain. What we want to do here is isolate the last point in time in the data and then use that to sort. So let's go about isolating this last point in time here. Let's start by console.logging our nested data. Note that for all of these values arrays, they have the same number of entries, namely 169. And if we access the row at index 168 in all of these arrays and look at the temperature, that will give us the sorted order that we want for the end here. The simplest approach here probably would be to sort right here before we assign nested, so that way we can keep this line the same and we can just add another line here, which is sort. Sort is a built-in method on JavaScript arrays, and it takes as input a function called a comparator function, where you can compare two elements in the array, typically called A and B. And what you need to return from here is -1, 0, or 1, depending on how these compare. Luckily, D3 has a utility called ascending, and there's also descending. So we can use ascending and pass in the, let's call it last temperature of A, and also the last temperature of B. And I'll put this on a new line here. This should give us what we want, but we need to import ascending from D3 and then also define last temperature. So let's start by importing that from D3. I'll just add that there. Import ascending from D3. And then let's go about defining last temperature. And keep in mind, A and B here are these nested objects that have key and values. So let's define it right here. Const last temperature equals a function that takes as input, I'll just call it D, and we want to return the temperature of the last entry in the values array. So let's think about just getting the last entry in the values array. We can say d.values at index d.values.length -1. That will give us the last entry in the array. And that will give us one of the original rows, and we need to get the temperature of that. But we already have a y value accessor function that gives us temperature. So instead of making this data set specific, I'm going to say last y value. And I'll use that when we pass it into ascending. And we can just take the y value of that row, y value of the last entry there. All right, that seems to have worked, although it is reversed. See, the pink one, Rio de Janeiro, is at the bottom, and the blue one, Geneva, is at the top, but it should be on the bottom. We can fix that just by changing ascending to descending. So when we import it, we should import descending from D3. And then down in the code where we use ascending to sort these nested values, we can just change ascending to descending. All right, that gives us the sorting that we want. See that? The blue line on the top is the blue circle on the top, Rio de Janeiro, Singapore, Bangalore, San Francisco, Shanghai, Boston, and Geneva. Now you have to do less work by matching these up with your eye because they're in the same order as that last point of the lines. That's all for line chart with multiple lines. Thanks for watching. Take care.